So, goeiedag. It's been a while since we did a video like this, but like I said, since not everyone finished it already in the during the lesson, I wanted to give you the opportunity to work on this exercise today, since it's a good preparation for Friday. But in the meanwhile, I will work it out myself, and I'll share with this. You can rewatch it when I share it with you. So it's about a Tesla Model 3, and apparently it's a very fast electric car. I believe most people are familiar with it. At a maximum speed of 250 kilometers an hour, it has a total friction force of 6,220.8 Newton, and we need to calculate the work done by this specific engine when it travels this speed for exactly an hour. So at the moment, when you see the word work, you need moet een belletje gaan rinkelen. So when you see work, you automatically need to think about this formula: work equals F times S. So if you you need to use this right at the get-go, because work is arbeid, so we need to calculate it. So the force is in this case the force that the engine produces. Given is the total friction force. However, when you drive a certain speed, or in other words, a constant speed, the friction force, the total friction force is equal to the force that the engine applies. So, because we know the friction force, we automatically also know the force that the engine produces. Both are in this case 6,220.8 Newton. So again, because it drives a certain speed, you can assume that it drives a constant speed, because it travels this speed for an hour, so constant speed. So therefore friction force is the same as the engine force. So 6,220.8 Newton, and we need to know how far it drives, because the S is the distance. If you drive 250 kilometers an hour for exactly an hour, I believe most of you find it very logical that you drive exactly 250 kilometers in an hour. Let wel op, de formule is the force in Newton times the distance in meters. So not 250 kilometer, but 250,000 meter. So again, this is the force of the engine. Het rijdt dus 250.000 meter, 250 kilometer. In other words, 6,220.8 times 250, 1, 2, 3, means that it produces a very large number of arbeid, of work. So 55,200,000 joule. For simplicity's sakes, let's give this number in megajoule. So 1 megajoule is a million joule. So we divide this number by 1 million. Dus nogmaals, 1 megajoule is een miljoen joule. So this is exactly 1555.2 megajoule. I prefer this because it makes the number less long. You could just leave this number and it's fine as well, because it's the same. You could even use 1,5552 gigajoule, GIE. Again, it's the same thing. So when you write this down, first you give the formula, V is F keer S, and then you give your calculation, 6,220.8 times 250,000 is 5,200 joule. Done. First points are in the bag. For simplicity reasons, again, 55,2 megajoule. Calculate the power of the engine. So power is always linked to two formulas. And especially in this scenario, we probably need to use this one. P equals the amount of energy divided by the time. So we just calculated how much work, how much energy is required. So we actually know this one. It's 1,555 200,000 joule. And we frankly also know the time. The time is the amount of seconds in an hour, or 60 times 60, 3,600 seconds. So I'm going to multiply this number again by 1,000,000. So this was the amount of joule it required, and the amount of power it needs to give is this divided by 3,600. So 432,000 joule every second, and we call that watt. Dus elke seconde 432,000 joule, or 432,000 watt. You could also again divide this by 1,000,000 if you want to, and you figure out that it's 0,432 megawatts. It's up to you. Or you could use kilowatts, 432 kilowatt. Again, up to you. Again, we write this down. P equals E divided by T is 1,555 200,000 divided by 3,600 equals 4,000 watts. Easy peasy lemon squeezy. When traveling at maximum speed, the electromotor uses 5.6 megajoule electrical energy per kilometer. Calculate how much electrical energy the car uses in 1 hour. So this is a kruistabel situation. We know it uses 5.6 megajoule in 1 kilometer. How much does it use after an hour? Again, in an hour it drives 250 kilometers. So if you know this is the energy it uses in 1 kilometer, then in an hour it uses 250 times this amount. 5.6 times 250, 1400 megajoule. Not too difficult, just a verhoudingstabel. So 5.6 megajoule times the amount of kilometers, 250 kilometers is 1400 megajoule. Awesome. Calculate the efficiency of the engine. So the efficiency is the useful energy divided by the total energy. And if you know this fraction, you can then do it times 100% to actually get a percentage. In our case, we just found out that it uses 1400 megajoule. So the motor uses 1400 megajoule in an hour. What we also found out is that the car itself uses 1555 megajoule in an hour for everything else. So 1552 megajoule, en een beetje volgens mij, 2 megajoule, die gaat naar de hele auto, maar 1400 daarvan gaat naar de motor specifiek. En wat zijn nou andere dingen wat we kunnen doen? Nou, denk aan dat online zitten, ze hebben een laptop aan boord, maar heel veel andere dingen verbruiken toch een klein beetje energie, lampen, etc. Daarnaast heb je natuurlijk ook dat er altijd energie verloren gaat en dat noemen we warmte. 1400 megajoules is the useful energy, 1552,2 is the total energy, times 100% gives me my efficiency of the electromotor. 1400 gedeeld door 1552,2 keer 100%. is 19,2%. Je mag hem ook afronden naar 19, maakt mij niet zoveel uit. Op een toets zou ik zeggen hoeveel je moet afronden. Zo, de efficiency. Daar hebben we niet echt makkelijk op dit. Dat volgens mij. Nee. Efficiency is 1400 divided by 1552, or 2 times 100% is 90,2%. Awesome. The range of the car is 530 kilometers when traveling at max speed. Calculate how much electrical energy can be stored in the batteries. So again, we know how much is used. It uses, so we know how much they use in 250 kilometers. So again, you can use a kruistabel. It uses 1555,2 megajoule to drive an hour, 250 kilometer. The maximum range is 530 kilometer. So how much energy does it use then? Oftewel, hoeveel energie komt er dan uit die batterijen? Question mark is always the one next to it and beneath it times each other, divided by the one diagonal to it. So 15,2 times 530 divided by 250 kilometer equals 1 per 2 keer 35 delen door 52 is a little bit under 3,300 megajoule. Let's round off to just megajoule. 3,297 megajoule. If you wonder why we didn't use this number, this is just the number for the electromotor. When you drive a car, you always need to look into the total energy it uses, because unfortunately it will always waste some energy. It cannot be helped. And that's it actually. So it uses this amount of megajoule. I'm not going to type it for time's sake. I hope it helped you a lot. Good luck on the test tomorrow.